the realms of chemistry and physics. Today I'm going to run through a few undergraduate to upper high school level physics questions, and let's get started. So here's the first question. The mass of Earth is 5.972 times 10 to the 24 kilograms, and its orbital radius is an average of 1.496 times 10 to the 11 meters. Calculate its linear momentum. Okay, so let's set this up. So we've got Earth, Earth, Sun. So the radius here is 1.496 times 10 to the 11 meters, and the mass is 5.972 times 10 to the 24 kilograms. Okay, so first we can calculate its angular frequency. As we know, the period, it's not given in the question, but we all know that the period of Earth's rotation is roughly 365.25 days. We'll want to convert that into seconds. So 1 day is 24 hours, 1 hour is 60 minutes, and 1 minute is 60 seconds. Okay, so these will all cancel through, leaving us with per seconds, which is the unit for our angular frequency. So if we run these all through our calculator here, then we get 1.991 times 10 to the minus 7, 1/seconds. Okay, so with an angular frequency in hand, we can calculate, so it wants linear momentum, so we need to calculate not its angular speed, but its linear speed. So that would be its perpendicular speed, or its speed perpendicular to its orbital radius. And we can calculate that with our known quantities, which is omega equals V over R, or V equals omega R, depending on how you remember this formula or find it. So that would be our angular frequency we just calculated, our radius of Earth's orbit, and then this will be our linear speed, or our linear velocity, perpendicular to the orbit. So V is 1.991 times 10 to the minus 7 per seconds times 1.496 times 10 to the 11 meters. And now running these through our calculator, we would get a linear velocity of 2.9786 times 10 to the 4 meters per second. And then I'm just going to move this all up. And so now we've got our velocity. And now with that in hand, we're ready to calculate our linear momentum. So momentum is just P equals mv. And we have the mass, our mass of Earth, which is given in the question as 5.972 times 10 to the 24 kilograms. And then multiplying by this velocity, 2.9786 times 10 to the 4 meters per second. Running that through our calculator, we would get 1.779 times 10 to the 29 kilograms meters per second. And so that would be our linear momentum for the Earth orbiting the Sun. All right, let's check this now with the solution given. So there's our, for the time period, they're just using 365, that's likely fine. And then they're just putting it all together, so rather than expanding the question as I have, just putting it all together into one equation, which is fine to do, obviously. And 1.78, 10 to the 29, so it's pretty much exactly the same, which is great. And so this is correct.